Hello guys, this is Trockers. Welcome to my channel. If you are new here, you are not lost. Just make sure you sit back, relax, enjoy. The math plane is about to take off, and today we are going to land on trigonometric equation airport in a few. Okay guys, like what I've just said, we are going to consider a Cambridge International AS and A-Level June 2025 paper 22. Right. The question reads, express 4 cos theta sine theta plus 30 degrees in the form r cos 2 theta minus alpha plus k, where r is greater than 0, 0 degrees is less or equal to alpha, less than 90 degrees, and k is a constant. Then the second part of the equation, hence solve the equation 4 cos 2 phi plus sine 2 phi plus theta 30 degrees equal to 5 for 0 less than phi less than 90 degrees. Right. So when you see a question, guys, the first thing to do is to read and understand the demands of the question. Right. So now let's go step by step. We are given this expression here, and we want to express it. So the end goal is to rewrite this into that form, right? And we are also told that r is greater than 0. I will show you in a few that r, you can also consider it when it's less than 0. But in this case, they want it to be greater than 0. And we have this range here for the value of alpha that we're going to calculate or to find here. It must be, or it must lie within this range, right? Then part B in math, this part here hence means use the above result, right? So we have to use the above result. Then we are going to solve. So the key word here is we are determining the solutions. We are solving, right, this equation now. So our job is to think like, how does this equation, how does it relate to the prior part or to the prior function, right? But remember, our final solutions, they must lie within this range. These are trigonometric functions. So when you see that question now, what should ring in your mind? Think about trig identities, right? Think about trig identities, think about quadrants, think about how we find solutions for cosine, sine, and tangent. No, these are some of the thinking process. That's the sum of the thinking process. The key points you should, ask yourself, right? So now let's tackle this problem. So we now need to do this problem here, right? So I'm going to need the whiteboard here, right? All right, sorry about this. I'm going to need the whiteboard. Okay, so the question reads, express. So we want to express 4 cos theta sine theta plus 30 degrees in the form r cosine of 2 theta minus alpha plus k, right? And we are told that r is, in this case, we are told that r is positive and our theta lies within that range and k is a constant, right? This is the, that's the given information, which is going to help us determine that. Okay, so thinking process, you need to relate these two. How how can I express this into that form? But let's go back a little bit to compound angles and double angles. So when you're talking about compound angles, we are summing two angles here, right? So maybe when you're summing a plus b, sine of a plus b, how do we do that? And it's not sine a plus sine b, right? But it's gonna be sine a cosine of b plus cosine of A, sine of B. So what it means is that when it's plus or minus here, you keep the sign. You don't need to change the sign, right? But the situation is different when we are talking about cosine, right? For cosine of A plus or minus B. So for cosine, it's gonna be cosine of A, cosine of B. Now you switch the signs, sine of A, sine of B. So, these formulas here, they are provided, right? But you just need to know how to use them, right? Then you can also think about double angles. So when it's double angle, obviously it's now cos A plus A, which is just cos 2A, right? Which is the same as saying cos A, which is just cos squared of A plus, in this case it's minus, I'm sorry, cos squared of A minus sine squared of A, right? Then I also want you to think about other identities that might relate cos squared A and also sine squared A. Make sure you have the answers written somewhere. Then we do the same for sine 2A, which is just the same as saying sine A plus A. So here it will be sine A cos A plus cos A sine A, which is the same as 2 sine A cos A. So you need these to help us to solve those problems here, right? So I'll go ahead and erase this part. I don't need this. All right. Just relax. So now let's begin the game. So we have 4 cosine theta sine of theta plus 30 degrees, right? So you can keep the 4 cos theta here, then you can expand this. And from the multiple angles, that is the same as saying sine 30 cos 30 degrees plus cos theta sine 30 degrees, right? As a mathematician, you need to know these exact values. For cos theta is root 3 over 2 plus cos theta sine 30 is 1/2. But if you don't know it, please make use of the calculator, right? They say you have to work smart, not hard, right? So now if I distribute this, I'm going to get 2 cos, or maybe let me say this. Oh, I'm sorry, I need this back. All right, let me say it's 2, let me just get rid of this. It's 2 root of 3 cos theta sine theta plus, if I distribute, it's 2 cos theta cos theta. So this, right, simplifies to, you can rewrite this as square root of 3, then 2 cos theta sine theta, then plus, here it's 2 cos squared theta. Now, let's think about the compound angles and double angle for cosine. Remember, I asked you to write this. So this one here, it is the same as saying, remember, this is just sine 2 theta, right? Then plus sine 2 theta plus 2, remember, cos squared theta here. Remember when I said cos 2 theta, it was the same as saying cos squared theta minus sine squared theta, which is the same as saying 2 cos squared theta minus 1 from your identities. Remember, sine squared theta plus cos squared theta is always 1, right? Then if I add here, it's the same as saying cos 2 theta plus 1, right? Divided by 2 is equal to cos squared theta. So here I can just say it's cos 2 theta plus 1 divided by 2, right? Then Here it simplifies to square root of 3 sine 2 theta plus here it's cos 2 theta plus 1, right? We have expressed, no, we are not yet done, but we have this part here, right? We have this part here, right? So I'm going to write it here. I need that part, so I will write it down. So this part becomes, okay, so I have root 3 sine 2 theta plus cos 2 theta plus 1. If I'm to relate now, as you can see, we have this part here. So we can easily express this part in that form, right? Then we now know that this k is equal to 1, right? So let's go ahead and express that part. So I no longer need this because I have written the solution down, right? Okay, so from there, maybe you can do it aside here. We are going to let square root of 3 sine 2 theta plus cosine 2 theta be identical to r cos 2 theta minus alpha. Then if I expand this, remember, if I expand that side, I'll get r cos 2 theta cos alpha plus r sine 2 theta sine alpha. So guys, you need to revisit your trigonometric identities. They are very, very important. Right, remember, I just have a few minutes and I have to think across several angles of trigonometric functions to come up with the solutions, right? So you have to be swift and at the same time relax, right? So now if I'm to compare, right, you see this cosine 2 theta is equal to that. So this here is in front of this, so we can compare it to 1. So now we can say r cos alpha is equal to 1. Then if I'm to compare, this is sine 2 theta, sine 2 theta. So whatever remains here, we compare that to square root of 3. As you can see, when we are dealing with trigonometric ratios, there are several ways, but I prefer this method here. I'll put my alpha. Cos is adjacent over hypotenuse. Sine here, it's opposite over that. Okay, so what I just did here was to say sine alpha is equal to root 3 over r. Then here, cos alpha is equal to 1 over r. So from the SOHCAHTOA, some they say CHASHO-TAO, from that mnemonic, you can know how to plug in those values for the legs and the hypotenuse, right? Then from there, we know that every time we see the right triangle, we think of the trigonometric ratios. We think of the Pythagorean theorem. So if I use the Pythagorean theorem, hypotenuse squared is equal to leg squared plus leg squared. So r squared is equal to 4. So r is equal to square root of 4, which is 2. So remember, earlier on they mentioned that r should be greater than 0. But I said you can also consider a case when r is less than 0. It depends with the question, right? Because once you take square roots, it's both positive or negative. So my r is 2. Then we need to find alpha, right? So when finding alpha, think of trigonometric ratios, right? So here, you know that opposite and adjacent, so that tan alpha is equal to root 3 over 1. So alpha is equal to arctan of root 3 over 1. So alpha is equal to arctan of root 3, which is 60 degrees, right? So my alpha there is 60 degrees. Guys, we are done. So now we know that. So now we then have to say, therefore, right, 4 cosine theta sine theta plus 30 degrees is identical to my r, which is 2 cosine 2 theta minus 60 degrees plus 1. Then we are done. This is the first part, and it is allocated 6 points. Oh my God, 6 points. This can change our life. Right.